Good morning. Today's my lecture topic is conduction mode of heat transfer. Actually, heat transfer modes consists of three topics. One is conduction, second one is convection, third one is radiation. What is meant by conduction? Conduction is one of the three primary modes of heat transfer. It occurs within a material or between material in direct contact. It involves the transfer of thermal energy through particle vibration and free electron movement in metals. No bulk motion of the material is involved in conduction. It typically occurs in solids but can also happen in stationary liquid and gases. The mechanism in conduction is heat flows from the region of higher temperature to the region of lower temperature. The rate of conduction depends on the temperature gradient across the material. The thermal conductivity is the property that determines a material's ability to conduct dust. In metals, free electrons primarily carry thermal energy. In non-metals, heat is conducted mainly through lattice vibrations. Fourier law. In conduction, Fourier law is the main law which is applicable in conduction. Fourier law mathematically describes the conduction is Q equal to minus K into dt by dx. That is the formula for the conduction. The negative sign indicates that the heat flows from hot to cold regions. It is linear law applicable to steady state, one-dimensional heat conduction. Material properties. Metals like copper and aluminum have high thermal conductivity. Insulators like wood, rubber and glass have low thermal conductivity. Thermal conductivity varies with the temperature and material base. Composite materials have effective thermal conductivity based on their structure. Porous materials reduce conduction due to air gaps. Types of conduction. There are several types of conduction. One is steady state conduction. That is, temperature at any point does not change with the time. That is called the steady state conduction. Transient conduction means temperature changes with the time. That is called the transient conduction. One-dimensional conduction assumes heat flow in one direction only. Multi-dimensional conduction considers complex geometries and directions. Conductions can be isotropic or anisotropic. Applications. Not the applications of the conduction are used in heat exchangers and thermal insulation. Relevant in electronics for heat dissipation. Plays a role in geothermal systems and building construction. Important in food processing for heating and cooling. Determines performance of thermal protection system in spacecraft. What are the factors affecting conduction? That are thickness of material, more thickness, that is less heat transfer. Surface area, more area, that is more heat transfer. Temperature difference, greater difference equal to faster conduction. Nature and type of material. Contact resistance between surfaces. In engineering consideration, the conduction includes engineers use thermal resistance networks for complex systems. Fins are usually to increase the effective surface area for conduction. That is, fins means it is usually in the automobile engines. That is called the fins. In heat sinks rely on conduction to draw heat from devices. Multi-layer insulation reduces conduction in spacecraft. Contact conductions in critical joint and joint parts of machinery. The mathematical modeling, heat conduction equations are solved using analytical or numerical methods. Heat equation is a partial differential equation derived from Fourier law. Finite element method and finite differential mode are used for numerical analysis. Boundary and initial conditions are essential for solving conduction problems. Solutions help direct predict temperature distribution over time. Practical observations, cooking, result condition using stove and food. These are the use of conduction. Thank you.